Okay, so this is example 5 from your word problem printout. So you go ahead and cut that off and tape or glue that into your notebook. So go ahead and take a second. You can pause the video, get that in there, and then we'll go over this problem. So what I'm going to do is I'm going to write the know, what I know, as I read through this problem. So it says the radius of a right circular cylinder. So cylinder, that means that's a shape that has a circle top, straight sides, and a circle bottom, is increasing at a rate of 2 inches per minute. So we know it's a rate, so 2 is a rate. And let's look back at the increasing, it says radius. So that's dr dt, 2 inches per minute. And the height is decreasing at a rate, so height, rate, so that's dh dt, 3 inches per minute, so 3 inches per minute. Then it says, at what rate is the volume changing when the radius is 8? Okay, so we know r is 8 inches, and the height is 12. So h is 12 inches. Okay, everything is inches, so I don't need to convert anything. And then it asks 2 questions. So under our want, this is our want to know. At what rate is the volume changing? Okay, so that's the volume. Changing means it's a derivative. So that's dv dt. We want to know that. Then it has a second question. Is the volume increasing or decreasing? When they ask that question, they're asking about the signs. Okay, so we're going to have to say, is this increasing or decreasing? So whenever we see those words, those are key words. We need to go back and check our 2 rates. So they gave us dr dt and dh dt. We just wrote down the numbers. Okay, but what we need to do, since they do care about the increasing or decreasing, that's going to be the sign. So with rates, what we're looking at, increasing or decreasing, so we're going to have to see if this is positive or negative in the end. So we need to make sure that we recorded that with our 2 rates. So it says the radius of a right cylinder is increasing. So this is a positive 2. And then it says the height is decreasing. So this is a negative 3. So we are going to have to plug in a negative 3 for dHdt if we want to be able to answer the increasing, decreasing question. So just be careful. We don't always care about the signs because usually they're just talking about a rate. And they don't care about what's happening. But if they care about increasing or decreasing, that means we need to go back and check our signs. The only thing that can be positive or negative are derivatives, because remember, like radius, we're not going to measure that in negative 8 inches. Like we're not going to have, the side of a rectangle negative 8 inches or something like that. Okay, that's not going to happen. So it's just the 2 rates that they gave us that we had to check. So from here, we can get our formula. We know it's volume because we need dv dt. And they told us it was a cylinder. So this is something you'll be given, or you can go get it from your formula sheet. Okay, sorry, my cylinder drawings are not very good. So from your formula sheet, the volume of a cylinder is V equals pi r squared h. I don't know why I wrote that. So we need an R and we need an H, so we're not going to plug these in at all. So when we do our calculus step, we are going to be using the product rule. Our first function is going to be pi r squared. Our second function is going to be h. Okay, so just be really careful there. We do have r squared times h, so this is a product rule. So the derivative of volume is dv dt. And then our product rule is the first, so that's pi r squared, times the derivative of the second, so the derivative of h is just dh dt, plus the second, so I literally write h, times the derivative of the first. So we have pi r squared, so the 2 comes down, we have pi r. And then we took the derivative of r, so don't forget your dr dt. Those are very, very important, okay? So then, if we can get our answer, we see if we can plug everything in. So we have an r, they gave us r, it was 8. dh dt is -3. So just be careful there. We do need that negative because they're asking us about increasing or decreasing. Regular h is 12. R they gave us, so that's 8 again. And dr dt is a +2. So we're going to plug all these things in, multiply, we'll use our calculator. So we have dv over dt equals pi, and then r squared, so that'll be 8 squared. dh dt is -3 plus h is 12 times 2 pi. R is 8 and dr dt is 2. Lots of numbers to plug in there. So when we do 8 squared, we get 64 times -3 is going to give us -192. And we have pi on the end. We'll just leave pi. Usually they leave pi as a part of our answer when it's a problem that includes pi. If they have decimal options, then you just plug that into your calculator and get a decimal, okay? And we have plus, we have 12 times 2 times 8 times 2. So plug that into your calculator. You're going to get 384 pi. So when you combine these, we have -192 plus 384. We're going to get 192 pi. So, and since this is dv dt, the volume is cubed, so we are working on inches. So we have inches cubed per our time was minutes. So there's our dv dt. So let's go look back up at what we want to know. We have dv dt. Now we need to say if this is increasing or decreasing. So what's the sign on 192? It's positive. That means that this rate, dv dt, is increasing. So all we needed to say was it's increasing because our sign is positive. And that's it for the 5th example. Okay, so just be careful with your signs. We do need to pay attention to when things are increasing and decreasing because it'll change our rate. All right, so our last example in the related rates section is example 6. So you can go ahead and cut that off, glue it into your notebook, pause the video if you need to, but we're going to work on example 6 next. So we need to fill out what we know. It says a conical, so that means a cone, water tank with vertex down. So vertex means the point. So that means the bottom of our cone is going to be pointing down. It has a circle top. Has a radius of 10 feet. So R equals 10 at the top. And a height of 24. If water flows out of the tank, so this is the water flow, so that's talking about all of the water, so it's dv dt at a rate of 20 feet cubed per minute. And then it says out, so we want to be careful here. This is going to be a -20. How fast? So now we're into the question, so that's what we want to know. How fast is the depth of the water decreasing when the water is 16 feet deep? So how fast is the depth So remember, that's talking about how high things are. So, and how fast is a derivative? So that's dH dt. When the water is 16 feet deep. So it's 16. That can go under our no. And when they're talking about deep, they're talking about the height. So this problem is a little bit different because we have two heights. But you have to be careful here because these two are the initial. This is the overall, like the big shape. But remember, when we're talking about water filling, we're going to have smaller shapes on the inside. So this is the instantaneous. So the height, that's the moment that we're talking about. Okay, so those two are both H. We do have two H's in this problem, but this is telling us when. Okay, so just be careful with that. And that's going to be really important because we're going to use that in this problem. We can also get our formula. So we have a dV dt, so we know we're going to be volume. Volume of a cone is 1/3 pi r squared h. Okay, so again, if we don't need to use product rule, we don't want to. What we need to find is dH dt, so technically we don't even need r. So if we can replace r with something, that would be great. Okay, so here's how we do this. We set up, and this is very, very common. So this is really, really important. So star this or circle it or do whatever you want. Okay, but this is very important. This says, so we start with our initial and we're going to replace some stuff. So the initial, we're going to use r over h. So we're using a proportion. Okay, so r is to h. So r, they said r was 10. So we do 10. Over h, they said h started at 24. So we use our initial values for this. Okay, and we want to replace r. So we want to solve for r in this proportion. That's what this is, okay? So we multiply both sides by h. These cancel, and we have r equals 10 over 24h, which can simplify to 5 over 12h, okay? So really, we can get rid of r, and we don't need the product rule. So r is 5 over 12h. So we're going to take this r, and we're going to plug it in right here. So before we do calculus, we're going to help ourselves out. So volume is 1/3 pi, those won't change. R will, we're going to plug something in for r. What we're going to plug in is the proportion that we got. So this is 5 over 12h. And then we want to simplify this, okay? So we have 1/3 pi. 5 squared is 25. 12 squared is 144. And then h squared is h squared times h. And we can simplify that a little bit further. 3 times 144 is 432. 25. We have a pi. H squared times h makes h cubed. Okay, so this is our new volume. So what we did was we had two variables. So we used a proportion. I don't know how to say that. Portion? I mean, spell it, whatever. So we had two variables, so we used a proportion to replace one of them and make our life easier. Okay, so whenever they give you initial values, that's what you want to do. So then, now it's time for our calculus step. So we can take the derivative. This is volume. So dV dt equals, we have 3 times 25 over 432 pi h squared, because this is all numbers, so it just drops down. Okay. We took the derivative of h, so it has a dh dt. Okay. We're trying to find dh dt. They gave us dv dt is negative 20. So to get our answer, we're going to plug in negative 20 equals 3 times 25 over 432 pi. They gave us h, so remember this is when, so this is our moment, so this is when we use 16. So we have 16 squared, and we're finding dh dt, so that should be the only letter grouping that I write. Okay, so when we can like move all this over, okay, so 3, oops, change the color. 3 divides into 432, and you get 144. So we have 25. 16 is over 1, so we can put 16 squared up there. Times pi, we can also put on the top. This is divided by 144. We have dh dt equals negative 20. From there, we want to multiply both sides by 144 times 144. So these cancel, and I get negative 2880, big number, use your calculator, equals 25 times 16 squared pi dh dt. And then for the final part of our answer, let's just leave this like it was an FRQ. So we're going to divide 25 times 16 squared pi on both sides. So all that's gone. dh dt is left, so dh dt is negative 2880 over, we have 25 pi times 16 squared. And you can square the 16. If you want to combine those numbers, you can. But again, in an FRQ, you can just leave this. This is considered correct. And then height is measured in feet in this problem. And our time is minutes. So those would be our units. Okay, so that's it for this section. You can now complete all the problems on your worksheet, so you have the rest of the period to do so.